I could have 10 minutes for you to think about. Oh, the CTO takes the total 15 minutes for the listening here.
Yeah, I can take 10 minutes.
Okay.
I can keep track of the agenda as well.
Okay. Yeah, because the location, so we have much less difference. Shall we start?
Sure.
Yeah.
Hello, everyone. I guess we should start. We are already 2-3 minutes late. So this is the IETF 95 in Buenos Aires. That's the Anima working group. Autonomic networking integrated model and approach. So if you haven't been in the wrong room, still have time to exchange. For this meeting, we actually have 2 sessions. One today, on Monday for 2 hours, we are focused on the milestone work items. Another one we have on Thursday for only 1 hour. For that, we can have wider scope, but the milestones work items still have the priority. So if we cannot finish the milestone work item today, we may use some time on Thursday. Also, people are encouraged to work during the week, and the progress on milestone work item could be reported back to the working group on Thursday. This is IETF note wheel. Everybody should read it. Before beginning the meeting, we already hand out the blue sheets. If you leave earlier, please make sure you do sign it. And we need a jobber scribe. Anybody does jobber? Is there anybody on jobber?
There are a couple on Java, yeah.
All right.
I'll try to do it as good as I can.
Yeah, just give the slide number. Thanks B for minutes taker. And for this meeting, we also have the support for remote participation. We do have 1 speaker remotely, yeah?
Yeah, Michael and or Max.
Okay. Okay, all the slides already uploaded on the material web page for this meeting. So you can get it. And we have the mailing list. Everything should be confirmed on the mailing list, and the mailing list is the main working place in IETF. And you can find all the information from the working group web page. That's the meeting agenda for today. We cover all the 6 milestone work items: grasp, output struct, ACP reference model, and prefix management in large-scale network. Also introduce the open source implementation of ACP and the loss-bound BI. Any batch for the agenda? Okay, once, twice, go. Okay, that's for Monday. summary the status for our working group milestones. We have the grasp already on 04 version. It adopted last summer. It's now in good status. So after this meeting, we would like to get at least 2 reviewers to check the maturity of this group, this document. Then hopefully we may get working group next quarter afterwards. And also the same for the bootstrapping key infrastructure. The milestone is setting for the submit to ISG next month. We have the autonomical control plan adopted also last summer. It's in 02 version now, and the milestone would be submitted after early meeting. After last meeting, we adopt 3 drafts, 2 use case drafts, stable connectivity and prefix amendment. They are simple, they are verified the use of the other components. Both drafts are in stable stage, target for the September submission. And finally, we have the reference module, which try to cover most of the Anima infrastructure. So that one is the last one we hope we finish. Michael, today we are giving a very detailed introduction on the reference module. That's the December this year target to submit to ISG as informational document. Then that means we are on very good track for complete our current milestone. That means, in current charter, we as milestone we had one say we target to recharter or refocus scope or close by the December of this year. So that if we keep on track, that would be possible for recharter on December. From the very beginning of this working group, we actually have second session for all those meetings. We run the second session as forum for potential future work items. So up to now, we already have several non-current charter work item being discussed: autonomical intent distribution, coordination, exchanging, and also a various autonomical service agent. That could be some potential for the work item in the next charter. If we keep on track for the current milestone work items, for early meeting we could have more time to discuss the potential work items. So we are calling for more potential work items. There is one relevant workshop we put on for research and standards for self-managing 5G networks workshop. We are calling for participation. It's in the Euro Conference on Network and Communication in Athens, Greece in June 27th to 30th. It's merged in a half-day workshop with network machine learning. Hopefully, we'll also discuss the new research items for the studies in the IETF and propositions of the evolution of the Anima work group recharter. There's another work happening in ETSI NGP ISG. It's next generation protocol. Yeah, they had a work item, self-organization, control and management plan. So they are calling the individual contribution on autonomic. So that's not for the Anima official, but just call the individual contribution there. It also introduced the machine learning as a mechanism for autonomic decision in autonomic network. Okay, that's it. Let's back to our agenda. The first one, grasping. Want to use this?
Hello. Good afternoon, everyone. This is Bin Liu presenting the latest version of the signaling protocol. Next, please. Okay, today I'm going to introduce the technical update since last IETF, as well as some remaining open issues. And we also would like to introduce you the second prototype, which was developed by Brian using the Python language. Next, please. Okay, in the 0.2 version, there are some main changes. The first one, we add the optional error string to the decline option to indicate the reason why the autonomic node declined the negotiation. And we also reduced the degree of the private enterprise name from must to may, because we also listed several alternatives to the pen naming. And the most significant change in this version is we separate the unsolicited synchronization as a new message. We name it as flood message. In this way, we believe it's more logically clear and it's more simpler for message coding. And we also include a new initiator ID field in the discovery response and the flood messages. Next, please. In the 0.3 version, we split the request message because previously we used a flag to distinguish the negotiation request and the synchronization request. But we thought it's better to make them distinct in the message level. And we do some repeat work of adding and deleting and adding back the initiator ID, because at last we finally realized it's necessary to include this field with the session ID to uniquely identify a message for loop avoidance. I'll discuss it in details later. Next, please. Okay, now it's the list of the current messages. The discovery and discovery response, these are as same as previous versions. And the request synchronization and synchronization, flood synchronization. And the negotiation is as the same as previous versions. And we also include a new no operation message. This is mostly for practical intent, because sometimes the developer might test whether the grab stack is on or off. So this is not for the real work. This is just for practical. Okay, this figure describes the looped message situation. As we can see, when the relay sent the multicast message to the link, and finally it will receive the message flowed back to the interface. Next, please. So we added a mechanism to address the loop avoidance. Just as I said, we use the session ID plus the initiator ID to uniquely identify when message has been sent to the link. And each relay device must record these ID bindings when it relayed a message to the link. And when the relay devices receives any multicast messages, it will check the cache whether it's already sent previously or not. And the cache need a timeout mechanism. We recommend to use the default timeout in grasp definition. But there's a worst case that this mechanism cannot address, which is when the looped message arrives back to the node, the cache timeout just exceeds. So in this situation, the loop account mechanism will act as a double insurance for loop avoidance. Okay, this is a brief information of the Python implementation by Brian. And you can download it in the link. And we also encourage you to play with it to find some bugs. And Brian also implemented two very simple SAs. Next, please. Yeah, this is the simple test bed for the implementation in Brian's office. There's a IPv6 switch and the two SAs installed on Linux and Windows. And they just worked fine as the test so far. Next, please. So there are several remaining open issues. The first one, we need to check against the other Anima working group documents, the reference model and the ACP, whether there are some inconsistent technical gaps. The second one is the rapid mode. Now the rapid mode is limited to only one objective, but ideally we hope it could be expanded to multiple objectives to enable the rapid mode. This needs some more design. And in current draft, there's a appendix, the analysis of current protocol. We hope to remove it before publish. The last one is we are wondering whether the reference model can include some text discussing about the multiple instance of grasp, because in last IETF we discussed in default, by default, the grasp should be running in the ACP tunnel, but we also might have some exceptions that it not running in the ACP model. So there might be multiple instances. Next, please.
Michael, any comments on that? Okay.
Okay, we need more review, And we also encourage people to play with the implementation code. We now have two independent implementations. The first one was published last year, and the second one was recently finished by Brian. And even you can develop your own prototype to find more design issues of the protocol. And this morning we just submit a new individual draft, which is the Grasp API. And in the draft, we propose some ideal API design. The API in the draft was not consistent with the two implementations because the implementation is mostly for examining the protocol design, and it does not include very considerable API designs for the ease of ASAs. But when we design the APIs in standardization, we need to consider to include some common functions in the Grasp-based module so that we can reduce some unnecessary repeat work for the ESA developers. And this new draft is totally open for discussion, and we hope you can review it and make some comment. And we need to make sure what's the boundary of a proper separation from ASA to the Grasp. Okay, that's it. And any question?
Hi, B. I actually had one question here. Here you list three APIs. Is that one instance or three different instances?
Three different instances. This is just for some information, not necessarily means which one is better or which one is worse. Because when they implemented the prototype, it's naturally they will sort out some APIs, but maybe that's not a very ideal API for future ASA development consideration. In this draft, we proposed some APIs designed totally by imagination, not based on the real implementation.
Okay, but as far as I can say, two of them actually from you. They are different.
It's not totally from me. Actually, the draft, the main content of the draft was mostly designed by Brian, and we discussed privately to make some revision. And the third one, the implementation was done by the BOPT.
Okay.
So at least they are from two independent teams.
Okay. But you do have the future plan to intend them as one.
Yes,
Okay.
exactly.
All right. Okay. Thank you.
Yeah, so thanks a lot. You'll see in the ACP draft that I'll get back to you in terms of trying to figure out working through these API and the other details for the use case of Grasp in the other charter items. So I think that'll basically give a lot of good collab to develop this.
Okay, thanks.
Okay. If there's no more question, the chairs would like to get 2 volunteers to review this document because we think this document is already relevant, mature. We would like to get volunteer review to check the mature list, whether that's good enough to to launch working group last call afterwards. Any volunteer? Michael?
By when do you need that?
What? Can't hear.
By when do you need
Can you talk directly into the microphone? The audio is really bad.
By when do you need that? So
When can you deliver?
it'll be a couple of weeks. That's why I'm asking.
Oh, that's fine. Couple weeks is fine. Maybe even a month. Yeah. So you want any?
And Michael Richardson also said he's read the draft.
Okay. To
He
Michael.
will read the draft.
Okay. So and 2 chairs will review that definitely. So we'll get at least 4 reviews to see whether this document is ready for working group last call. Thanks. Okay. So who's next? That's bootstrapping. Who will make
Right. So I think that was Michael Richardson.
online?
Is that
Hi,
okay?
am I here? Yeah, I'm going to speak instead of Max.
Right, we can see you, we can hear you badly, although that's just the audio.
You can hear me badly.
Oh, we can hear you.
You can hear me. Okay, good.
Yeah.
Figured out
I mean,
it's really important to put your slides in front of your camera so that you can actually look into the camera, it turns out. Okay, so these slides were done for this working group, a little bit for NetConf and also for Sixtish. And I guess some of the history that some of you may or may not know is that some of the zero-touch work started in Sixtish and NetConf and has kind of flowed around a bit. And then when the Anima working group got going, it became clear that we shouldn't be trying to do this in Sixtish, we should do it in Anima, keeping into account that there are some differences between what's going on. So the Anima Bootstrap design team has been meeting weekly. Thursday mornings has been up to this point at 11 Eastern, although we have not made a specific time for post this IETF. So if you want to influence that date or time in the week, that is an open thing to do at this point. And we have been going through what was originally Max's document, which is now draft IETF Anima bootstrapping key infrastructure. And we are making some significantly good progress on this. And I think there's only 1 or 2 items that are left before I think it is essentially done in a lot of ways. We've spent a lot of time talking about things like what goes into certificates, how they are exchanged, and what does it mean to bring up a enrollment over secure transport, which is EST protocol. So I'm just going to talk a little bit about some of the similarities among this work with other things and some of the other work with some of the other working groups. So next slide, please. So contrasting what Sixtish wants and what Anima wants, and I apologize if you got this slides 3 hours ago. Anima is really about bootstrapping into an enrollment over secure transport, RFC 7030. The purpose of this is to get a certificate, a locally relevant certificate into a new device such that it can bring up its ACP connection with a peer. Whereas Sixtish wants to bring up a CoAP 6-top transport to allow a join coordinator to push a bunch of netconf VAing down at the new device, which may also include Sixtish like scheduling things. Sixtish networks are constrained, the devices are code and RAM constrained, and they often are battery powered. So while Anima does not share this problem in general, many of our devices may be multi-gigabit routers with, many hundreds of watts of power supply in them. As they boot up, they could be as constrained as some of the devices, depending on where the ACP is running. So it's something to be aware of, that although we ultimately run on a potentially very rich device in some cases, even those most rich devices may be very constrained as they turn on. And of course, not every device is a multi-gigabit router either. Next slide. So contrasted a little bit with NetConf. NetConf is also about getting a channel to do some Yang-like things. NetConf or RESTConf or a bunch of other techniques. NetConf sort of is very, I don't want to say promiscuous, but very flexible in how it will connect to the network. HTTP, HTTPS, DNS, MDNS, DHCP, USB key is a way to get online, of all things, because that really just provides you with a redirection to something. While NetConf can update the LDEV ID as part of its Yang process, it's not ultimately the goal of the Bootstrap. The Bootstrap is to provide a generalized channel for configuration information, which might also include replacing the certificate. Whereas Anima, the Bootstrap process is get us a locally relevant certificate, and then let's do the rest of it. So finally, Anima is a little bit more focused on infrastructure equipment, routers, switches, access devices, this kind of stuff. Well, we haven't said really that's the only thing we deal with. A lot of our use cases tend to be more focused that way. NetConf is a little bit more focused on high quantities of certain kinds of appliances, telephones, access routers in people's homes, but it's neither are particularly limited in this way. It's just a particular way in which operators are coming into this. Next slide. And I'm mostly going to skip this slide because it's not about this working group, except to note that both 6TiSCH and NetConf care about Yang, whereas Anima does not particularly care about Yang as a part of the Bootstrap. It may care about elsewhere. Next slide. So what is the problem we're trying to deal with? And I realized I should have put this slide at the beginning for people who don't know what's going on. It's really about how to put a uninitialized, drop-shipped, potentially malicious node into a network without destroying the network. Drop-ship means that it came from the warehouse, that you don't know exactly which device it's going to get shipped to you, and you as the network operator may never actually see the physical device. It goes straight from the factory, as it were, to the network that's in the North Pole or something like that. You don't get to touch it. That's why we want a zero-touch solution. In this process, one comment I want to make is that some of the 802.1x EAP mechanisms that people have used quite successfully in the past for controlling access to the networks are essentially require an initial touch. They require the certificates of the network to be pre-installed. And so that's an issue. The second issue is that if you actually are using 1x functions on your network to authenticate end hosts, then it may be a bit confusing if you're also trying to use them to bring up new nodes, which may look like, infected PCs or something like this. So there may be some value in having a different mechanism for bringing up your ACP from your general access control. Next slide. So this is what the two different networks might look like. On my screen, the yellows are much paler than I intended. So you look at the PDFs in the archives if you don't see what they look like. So on the right-hand side, we have and potentially Anima network. The green lines are ACPs that we're trying to build. Then we have on the bottom that router, which is this new guy that's trying to join the network. Similarly, on the left-hand side, 6TiSCH, for instance, has join nodes and join assistants and has some kind of a mesh network that it's trying to build. So there's a lot of relationships there. In fact, if things go away, I think we will, that we'll be running the same routing protocol over our meshes, and that's an additional similarity. But the key thing I wanted to point out is the blue bubbles in the middle, that we both basically have this manufacturer installed certificate and a supply chain that provides an ownership voucher into the new system. So that's a commonality between the two, and that's a great deal of what our document is about, is that part. Next slide. And now if you contrast this to NetConf, Anima versus NetConf, you see the network diagram looks fairly different, but the blue bubbles are still there, okay? So we're still providing a manufacturer installed certificate into the end device, and an ownership voucher goes through a supply chain. In the NetConf, there's a process of referrals and other stuff where the device eventually finds potentially the NMS that it's really looking for, and things are all good. Whereas in Anima, we essentially connect that by a series of through our GRASP and other protocols. We basically hook the new device up directly with that, and there isn't a discovery process. The other thing to realize is that the piece in the middle between the telephone and the firewall and that cloud is not necessarily owned by the guy that owns the telephone on the NetConf case. Whereas Anima is in some ways more about infrastructure, so you presume that those pieces in between are owned, and therefore we can deploy things right out to the link layer edge. And that's a subtle difference, and I think it's pretty important, but it does reflect why there's a difference of approach between the two things, and why we actually do need different solutions for these different scenarios, but yet the blue bubbles still remain the same. Next slide. And then we've had a lot of conversation about exactly how do we do the proxy process. In other words, how does the proxy help the new node get online without giving it unfettered access to the internet, without doing all sorts of silly things that we don't want to do. And the proposal that I like the best is essentially one where we tunnel link layer packets to the registrar and let the registrar sort it out. So essentially we're moving the problem from the edge of the network to a purpose-built machine that will deal with the problem of how to do it and how to get the link layer addresses back through the correct tunnel, those little key-like green things on the right, so that they go back to the right assistant and go back onto the right link layer. Next slide. To that end, I wrote a document which is referenced at the bottom that kind of explores the 5 or 6 different ways that we can do things, and looks at the state cost for the join node. Because one of the things I think is very important is that if the join node is going to be a join assistant is going to be willing to do this function, it has to be as cheap and simple as possible, such that option is as available as possible. There's a bunch of bubbles and stuff missing from this slide, but oh well. So that we looked at 2 things. We looked at HTTPS and we looked at CoAP DTLS. We looked at forwarding them via a circuit proxy. So that essentially means something like a good old application layer gateway. If you're familiar with 20 years ago's state-of-the-art in firewalling, that's essentially a process per connection that gets created. You can do it, point 2, you can do it through some kind of a NAT process. You can do this through HTTPS or DTLS, which is just COAP, it's just UDP. And I don't particularly like either of those solutions because it involves a bunch of state on the proxy assistant and includes the words NAT. So that's why I proposed the 3rd solution, which is that you statelessly IP encapsulate this link local traffic, you send it to the registrar, and you let the registrar work it out. So yes, the registrar has to keep state for every potential malicious node that's joining, but only the registrar keeps that state, and that machine is designed to basically do this. It does cost some bandwidth. It means you are pumping potential malicious traffic across your network, and this is a big deal in constrained networks. And so regardless of what you do, you want to limit that traffic to how much you're actually sending across it. Now, one of the things we did do in our document is we actually made it completely agnostic to the joining node, which one of these methods we are actually using. So we've designed it such that you actually could do any of those 3 things, and the joining node doesn't really care, to the extent that it has to pick either CoAP DTLS or HTTPS. So it has to pick one or the other to do. And so CoAP DTLS potentially has the lowest code issue for any kind of constrained device, but on the other hand, it may be a new protocol for in some environments. And I think that's the last slide. Questions?
Michael, this is Xing. I do have one question for you. how do you think this document is mature for public? For publish?
It is not ready for a working group last call. It is working group ready for wider working group review and discussion. There are a couple of pieces that key pieces which this document does need to define, which it does not yet do. One of them is running EST over COAP blockwise mode needs to be clearly articulated as maybe no more complicated than the words I just used, but it doesn't need to be said that this is what we're doing. And there's potentially some other bits and pieces which we need to write down as to what actually goes in the certificate. We have some pieces there written already, but I think that they probably need to be tested against other people's ideas as to whether they make sense.
Okay, thanks. So we did have the milestone to submit it to ISG this month or next month, but of course quality will go first, get the priority. The chairs would like to get 2 volunteers to review this document. Anybody volunteer? Padma, would you like to review it? No? B? Could you help? Okay. Can we get 1 more reviewer for this document? For this draft document? Okay, we'll call reviewers on mailing list. Yeah? Okay.
And so Max was also saying that maybe if we have 2 or 3 minutes on Thursday, then he could also summarize a little bit more the changes in the revisions of the document, because that failed to deliver today.
Okay, could do. Thanks, Michael. Okay, next will be SAP. Michael? Oh, that's you?
Okay, so this is update on the autonomic control plane O2 draft. Next slide. So there are basically 2 big block of changes. One is that the addressing draft that Michael had started out as a separate draft, that discussion with the working group chairs. So it's primarily, part of the ACP. So that's why that whole stuff got into the ACP. But then we looked at how much time we have. So there isn't that much changes, but there were a lot of concepts that we hadn't really gotten good feedback on. So Michael is going to talk about that in the next slot. And the other big change is that I added text to the ACP draft of explaining how the ACP is brought up so that we get closer to actually being able to implement. And that was primarily of how we leverage GRASP and do the negotiation. And that also means that there's a little bit of slide at the end of this deck showing how the Bootstrap would integrate with GRASP, also with what we have partially written in the Bootstrap draft already and what's open and to be done. Next slide. Oh, all the colors are gone. Black and white. Did you see the colors?
Yeah.
Yeah, it's all right. Well, hopefully it doesn't make too much of a difference. So here's basically the first, and I like the word instance. Brian doesn't like the word instance, so that would be a really good discussion to have how we best verbalize that. So this is what I call the first instances of. Even if they don't see me, it's just, so this is the first instance of GRASP where basically the device knows it wants to be autonomic, doesn't do anything else. The only thing it tries to find through GRASP is link local candidate neighbors, right? So the only thing it tries to discover is the IPv6 link local address of a possible neighbor. And then basically, once it discovers one, it has to ask itself, am I already autonomically enrolled or not? If I'm not autonomically enrolled, I'm going to basically start trying to do enrollment as specified in the Bootstrap and that neighbor is going to be my proxy for EST over TLS. And that's what I'm going to get back at the end. And the core for us in the ACP, of course, is I am already enrolled. I'm trying to build my ACP to that neighbor. So this is a really silly, lame, simple instance of GRASP, just trying to find the IPv6 address of a candidate AN neighbor. Next slide. So lots of details here. I was suggesting in the text some refinements of the GRASP text just to make sure that there is never caching of information, that we may be using this trick with the TTL 255 to make sure that these packets never get forwarded. So all these standard things, and we can review those in more details. And I think Brian was okay with most of them. For security reasons, we want this discovery not to be used for anything but returning the IPv6 address of the neighbor, because anything else that we're returning from a neighbor is a possible attack vector, right? So having said that, I think, and this is optional, and maybe, you know, that I'd love to see feedback from others, I'd love to include additional information purely for operator diagnostics, right? I'm basically on a device, I see a neighbor, and the only thing I would see is a completely secure neighbor that I know IPv6 address, something fails, it's really hard. So maybe some diagnostics in there in this level would be helpful for an operator. But I haven't written anything into the draft right now, but that would be the only thing permissible, I think, in the insecure part initially, diagnostic. Nothing that impacts the next step of building the ACP. Next slide. Okay, so here's the great discussion about all the different reasons why we've been thinking of GRASP in this place. So the obvious contenders were things like CDP or MDNS and so on. And so there are a couple of reasons I listed here. So on one hand, this can be very lightweight and simple for the dedicated purpose. MDNS is a very generic solution, right? So you need at least 4 types of resource records to find a DNS service. And then also because it's so generic, right, I can run into all type of things when people start using MDNS for a lot of other purposes, like, you know, autonomic device pops up in my application browser beside printer and iTunes. Or somebody sets up what we've seen very often, MDNS forwarding across multiple networks, and then I'm seeing linked local addresses from other lands, and so on. I can't use CDP LDP because they wouldn't be forwarded by a layer 2 switch. So I want to get with my discovery across some non-autonomic capable layer 2 switches. But instead, what I want to be able to do as well, which is also why it's good to have our own protocol, is that I want to be able to run this discovery on a layer 2 switch that is connecting multiple routers. And then if I have a LAN with an autonomic capable layer 2 switch and multiple routers, I don't want to build a full mesh, but I just want to build an ACP connection from each router into that switch. And that means that the switch has to intercept these packets then. So those are a couple of reasons why my feeling is that GRASP, even though it's a very simple thing here, would be, as a protocol that we own and define for the purpose, be ideal. Next slide. Okay, so now we get to the next level. We have discovered a neighbor, and we're trying to negotiate what security protocol we want to use for the ACP connection. And so the first step here that I'm proposing is one that doesn't require a mandatory to implement negotiation protocol. So the idea is each device implements a couple of possible protocols. Let's call here IPsec, DTLS, DIKE was another draft that Cisco had in the IETF a couple times back. This one, only these two. Basically what happens is as soon as one of these connections comes up, we have a tiebreaker. The tiebreaker says that the device that during the authentication of the connection that works has, let's say, the higher device ID in its certificate. That's the tiebreaker winner. The loser is going to stop building additional connections, and the winner is basically deciding whether it wants to try to build an even better connection and ultimately tear down the security associations that he doesn't like. So ultimately, this is arriving at the one security association supported by both of them and preferred by the winner of the tiebreaker. So this is the very simple scheme to allow building alternative security associations without any mandatory to implement single negotiation protocol. Next slide. And also recognizing that I think it is good for Anima to be able to build optimized implementations that only have subsets, because it's not in general necessary for all possible autonomic devices to talk directly to each other, right? So one simple example I came up here is consider a big enterprise. Let's say MACsec would be, because of hardware acceleration, a cool thing to do in an enterprise. All low-end layer 2 switches would do MACsec. But then we have this total other world which hangs off the edge of an enterprise. Let's call it the IoT world, where everybody wants to do just DTLS because they already got DTLS code on the application layer. They want to save code space. Et voila, it seems easy that, well, most switches only need MACsec. IoT devices only DTLS, and only the gateway devices, which are known to interface between an enterprise and that IoT space, need to support both of them. And I can implement and really only need the code space and the implementations on the devices that I need. And negotiation protocols, right by themselves, they can be as heavy as the full encryption thing, because the whole authentication part needs to be the same. So this is the first stage that I'm proposing for the setup of the ACP channel. Next slide. Oh, so yeah, so the authentication, that's simply just in more detailed refinement what we already had in the reference model, right? So the authentication must always be based on the domain certificate, right, signed by the same CA. It must be valid, and the domain name of the peer and ourselves encoded as OU part of the subject, and must be the same thing. And I have at the end of the slides kind of the point that maybe these details all should go in more concrete into the bootstrap graph. So that's possible to do if we're missing things, and we're missing the addressing pieces, right, in the certificate for the ACP addressing. So that's still to be worked out. Next slide. So now, having said this, we do obviously want to have negotiation of this part, just not as a mandatory to implement all the time. And so the trick to do that is basically say the negotiation protocol is just one of the options that we have in the beginning. And the proposal here for the negotiation is to use GRASP over TLS. TLS gives it the security, and then GRASP itself would be embodying the negotiation. And so if basically both sides support GRASP TLS, they would prefer it. So basically that means in the first step, they build a GRASP TLS connection, they negotiate what they both like best, and they end up at the actual secure channel protocol, for example, IPsec. Next slide. So why do we want to have negotiation, right? I think in before we hadn't gone into a lot of details of what would be good things to have in negotiation, and thinking about that more, I came up with 3 categories that are good for negotiation. So first of all, the tiebreaker that I had, like, you know, the guy with a higher device ID decides, is not really a good generic option. Secondly, there are some negotiations between protocol variants that we can't even do without a separate negotiation protocol. And the third one is we can also, therefore, when we have a secure negotiation, extend the channel protocols into those that can't work with the domain certificates. Next slide. So the tiebreaker, the most simple example I could come up with when the tiebreaker is not a good solution is if you simply think about, I want to select the protocol that gives me the best performance. So now basically I have protocol 1 being hardware switched on router 1, protocol B hardware switched on router 2. Well, I don't get hardware switched in both of them, so I need to compare, you know, which software performance is best, right? So that's one example. And if I would simply take preference as the achievable throughput, and I'm looking for the minimum same preference, I'll basically get performance negotiation out of it. The negotiation between different variants of the same protocol, that's more obfuscated. I was talking with our IPsec experts. So there are 2 layers that are difficult here. So we have seen IPsec being used with different encapsulations very commonly. Very often it has been done in the past, and hardware supported GRE over IPsec, but you can also set up IPsec natively, where you just have the payload in IPsec without GRE. It's practically in many implementations impossible to negotiate between them, because you have to assume the security association encapsulation step up front, so that won't work. Theoretically, it's not quite clear whether through the IPsec negotiation it would theoretically be possible. So we're still working through that. But we already know that in our products it would be practically not possible to do that negotiation unless you have a separate negotiation protocol like GRASP first, decide what the stack is, and then build up that tunnel stack. Next slide. So the third one is really if I start to not only negotiate which protocol I want to use for my secure channel, but also parameters of the protocol. Like, for example, a master key that I would negotiate, session key, and then I pass it on into things like MACsec, 8.1ae, as basically their initial key that they use, because MACsec by itself cannot be built off of certificates, and we need this to be built off the domain certificates. So that's basically, you know, the most important part for building the ACP. That's this GRASP instance. And I think for the next round in Berlin, we need to figure out what's the minimum sufficient details of GRASP negotiation that we feel to go into the ACP, so that we can call on that part for the ACP draft to be done towards last call. Next slide. Yeah, and basically for this type of negotiation that I was talking about, I'm not even sure if we would even have any good contender towards GRASP. So I think this looks like a perfect option to use GRASP for that. Next slide. Yeah, next slide. Okay, so third use of GRASP within our charter items is basically asked with a GRASP within the ACP, right? So here we've got the insecure one, discover the neighbor. Here we've got the TLS secured one to negotiate the neighbor channels. Then we build the ACP. Each secure channel becomes a virtual interface. We do IPv6 forwarding, routing with Ripple, all the good stuff. Inside the ACP, we have now a full-blown instance of GRASP, which is secured by the ACP and the fact that it's only running across the secure channels. And so that's doing interesting things like discovery forwarding and discovery and service negotiations for different ASAs. Most of that is going to be future work items. So the real only validation case that we have within the current charter items is the bootstrap. Right? In the bootstrap, what we need to do is that the enrollment proxy discovers the address of the registrar, or one out of multiple registrars, which can be many hops away. And so that's basically the validation case that we need to work through and define in enough detail that it can be implemented, in my opinion, in the bootstrap draft. Next slide. Next slide. And this is basically kind of the picture for the bootstrap that I promised. So we've got our device that's not enrolled from the beginning, right? And what's the role of Bootstrap? The role of Bootstrap is you have a manufacturer installed certificate, or kind of a silly, stupid thing that vendors do, which is insecure, a UDI, and you want to derive an AN domain certificate from that. So we already said you discovered through GRASP a possible neighbor. You're sending your EST TLS connection to it. Well, this guy is also not enrolled, so that's failing because it's not having EST TLS proxy running. Now you're trying the same to this guy here, and he actually is in the autonomic network, has the ACP built, so he's running the Bootstrap proxy, let's call it an ASA, and that one is proxying EST over the ACP back to the registrar. So for that, it needs to know the registrar's ACP address. So this is basically the learn and announce part of GRASP inside the ACP that we would have to specify well enough that it can actually be implemented interoperable. Next slide. Right, so this is basically just the summary of those open pieces that we want, right? So finalize the specification, detailing the GRASP message payloads for these three uses of GRASP. There are a couple of Ripple parameters that we haven't specified well. Pascal Thubert gave us good input on that, so that just needs to be integrated. Complete set of requirements against the content of the cert that might both best get into the Bootstrap document, so maybe out of the ACP document. And then as far as addressing is concerned, Michael will talk more about that. As far as current target for the ACP would probably be only fully specifying the use of zone 0. Next slide. And yeah, then there are a bunch of additional, thoughts we have in the document that we may not get to fully specifying out in detail. So we may want to mark these as architecture items so that it's clear that these are targeted extensions without necessarily being fully specified within the current target RFC for the ACP. All right. Hey, 5 minutes for questions. Sorry, it was a lot of stuff in only 20 minutes, but
Hi, this is Stuart Cheshire.
I don't expect to change your mind about anything, but your reasons for not using MDNS seemed like a bit of a stretch. The claim that devices would start showing up as loudspeakers or printers is a bit far-fetched, because the terminal room printer doesn't show up in iTunes as a speaker, and your speakers don't show up as printers. So why service discovery would suddenly start breaking with this when it works for hundreds of other things seems a bit contrived.
I was worried about this piece. If you can put my, worries on this point at ease, that would be great. So definitely, I'll ask you how that can be avoided. I'm not quite clear on that.
Sure, we can talk about that. Well, actually, it might be helpful for me to just answer it quickly now. Every service is advertised with a type, and printing is a type, and audio output is a type, and screen mirroring is a type, and the Anima protocol would be a different type. So if you're looking for Anima, you find Anima. If you're looking for printers, you find printers. If you're looking for speakers, you find speakers. The idea of service discovery is you find what you're looking for, and you don't find other devices that are not what you're looking for.
Right, and I wasn't quite clear how common it would be to trying to display to users all type of services that are discovered.
There actually is no way to ask for all types.
Okay.
The query includes what type you're looking for and returns those results. Okay. There is no star, there is no wildcard, there is no all types option.
No, okay, cool. If I can remove that point, I mean, there's still two other points remaining. I mean, we've been going back and forth on this part between MDNS, and Grassman was trying to find criteria. If this criteria goes away, fine.
Max?
Hey, Torlin. You mentioned a couple of times some of the Bootstrap integration, and in the context of discovery, it wasn't clear to me. Did you think that bootstrapping had to complete so that you had the credentials to do the discovery? You said something about MaxSec not supporting certain credential methods, and I wasn't quite sure what you were getting at with that.
So as far as understood it from Brian, he told me that there is currently no standardized solution to do the mutual authentication based on certificates within the scope of the standardized MaxSec solution.
Okay, so if MaxSec was using, you would have to complete the bootstrapping to understand that you had a particular type of credential and you couldn't use MaxSec, or the idea that MaxSec was being used would change how your credential enrollment would happen?
No, the idea would be, just as an example, whether it's a good example or not, that you basically have systems like MaxSec where you can start setting up a connection by telling them a master key, and that you can basically use Grasp to negotiate the master key. So whether or not for MaxSec that would be preferred option, I didn't mean to imply.
And the statement that you would use Grasp to negotiate the master key rolls bootstrapping into Grasp, and I think I would push against that. But we'll take that conversation.
Well, I'm just saying for expediency, right? Because the idea is that I need a negotiation anyhow to figure out whether I want to use IPsec or DTLS or MaxSec. So I'm doing that negotiation after I've already done the expensive TLS connection authentication on that one. So then the point comes to, I want to repeat that whole TLS certificate authentication that I've already done, or do I simply want to, leverage the master key that I can derive from that TLS connection and feed it into my secure channel protocol that I use afterwards. So it's an optimization, so to speak, in that case.
Okay.
Okay. Bing, could you or Brian Carpenter to read this draft and help to check the consistent with Grasp? Yeah, because your guys also modified Grasp along. Yeah.
I think it's consistent, right? I mean, I've been talking with Brian about that, but of course it's not complete, right? We haven't filled in the actual things in the three pieces, like do we need some registration of the objective in these three cases at least, right? What other payload information do we need? So I think that's what we need to work through and add. Mm-hmm.
Okay, thank you. So Michael?
I think I messed up the microphone. So.
You have 40 minutes. 40.
Excellent. Thank you.
Go ahead.
Okay, straight to the next slide. This is about the reference model. Just a quick reminder for those people who do not follow Anima every day, what this looks like. There's a big red line. At this moment, we are underneath the red line. Everything in the charter at the moment is underneath the line. Everything above is outside charter right now. That does not mean we don't need to think about it. Those are the autonomic functions that will eventually use the infrastructure. The infrastructure consists of elements such as grasp, the bootstrapping, the ACP. Basically, all the drafts you see in the Anima working group are here somewhere. And as you've heard many times now, that all comes down to a domain ID, this LDEF ID that Turles mentioned earlier, that every device has, with which it can authenticate itself towards its neighbors. On top of that sit autonomic functions. They use that infrastructure to communicate. Autonomic functions do not have addresses. Addressing is all below the red line. Okay, just as a reminder. Next slide, please. So now going through the draft, I'm happy to say that I think we are getting clarity on many points. There are still open issues, of course, but overall we're making nice progress. The naming section was updated quite a bit because the last draft contained a particular proposal on how naming should be done, and we took that out again. Now we're just saying there should be some form of naming, but it's essentially up to the implementer to define what that naming scheme could look like, and everybody could do that differently. So we've now changed it that it's to those requirements: uniqueness, consistency, autonomic, i.e. the scheme is such that it's automatic and you don't have to do anything manual. There's still a few phrases in there, and by the way, there are still a few phrases all across the document that we do need to think about more and clarify, so work is still to be done. Recommended that the names are generated by the autonomic nodes themselves. That, if I remember, at the very beginning of Anima, there were lots of people who thought we should not do that. The addresses and names should be assigned by the registrar. These things need to be sorted out yet, right? And there's actually the other question: do we actually need naming? We could just do with addressing, and I'm a big fan of naming, but I'm not the only voice. Next step. So the addressing section, first of all, I explain what has changed, and then I'll go into more detail what still needs to be done. So the addressing section has moved around 3 times now, I think. I'm sure it will a few more times. Right now it's in the ACP draft. So the addressing draft that you may have seen is now dead, but the whole content, basically byte by byte, has been shifted into the ACP draft now. So it's all there. Other changes, section 4 is the sequence of events, the elements in the autonomic infrastructure. I've just reordered that because it seemed more logical. Again, no guarantee that that won't change again. And also, if anybody has good input on that, please bring it forward. So it's coming nicely together as the document that holds the whole solution together. For each section, we point essentially to a draft that describes then how to do it in detail. And as we've just heard from Turles, in the Bootstrap draft and the ACP draft, there is also now protocol meat getting into it. We are starting to get to the point where we actually really have a solution that is end-to-end defined. But yeah, there's text on the MASA now, which wasn't there before. Subdomains, cross-domain wasn't there before. The intent section has been changed, just editorial changes and some text changes, and also the aggregated reporting section has changed.
Just one question. I'm not sure the intent discussing is in the charter.
Nobody had that.
Sorry. A question. I'm not sure the intent section is in the charter.
Wait. Yes,
okay.
This is a different question. Yeah.
All right.
I'll come to that in a second.
Okay.
Okay. So now, next slide, please. No, sorry. Here we are. Now the open issues, what we need to go through, and those of you following the mailing list, I read through the entire document top to bottom, and just wrote down what I saw that needs still addressing and needs still changing. And that's basically that list here. So first of all, the naming. The first thing is, do we need naming? I think yes, and I'll illustrate later why I think we need naming, because we also may have different addresses for the same node depending on where it is, in which zone it is. Therefore, if we want an autonomic function not to need to worry about following which address change has happened on the other side, we better have a redirection. Now, that is adding complexity to the current solution, and it is one thing that we could decide to move to a phase 2, to next rechart or whatever. All of these things are things that we need to discuss. My personal preference is we fix it, we write it down. It's not rocket science, right? We've done this before, and then it's done. And most of all, then we can get into the mindset of using names rather than addresses. A specific naming convention is out of scope, so that is clear. We don't want to really impose how the names are constructed. But at the end of the day, it'll look something like this, right? So you have the domain that comes in as part of the setup of a domain. And then there will be a node identifier that has to be constructed somehow in a mechanical way. The idea is that this should not be done by the human. This should not be the host name of the device. I'm very strong about that. This should be something autonomic, something that is not related to the manual operation of a network. So this is a different ID. And we can see how we can match that to the real world ideas, so to speak. But I think it is a separate ID. And then how we construct that, here's an example of how it could look. It doesn't have to look like that. And at the end of the day, from an architectural point of view, from an IETF point of view, we don't even care how somebody who runs an autonomic network actually would construct that name, as long as it's unique. Okay. However, if we have naming, and there is concerns for Max and Michael again, if we want names, I think we want them in the domain certificate. And that is something that is not being written down in detail. We've talked a lot about different fields, but the full format of the domain certificate has not been described yet. If we decide to do naming, the name should be in there. Right, yeah, that's what I just said. Okay, next slide, please. So addressing, again, the text here is actually in the ACP draft. Don't ask why we discuss this now. Main thing is we discuss it, right? So we have, this is a slide that I showed also in the last IETF. There was no pushback, but there was also no discussion, and that starts to bother me. And I would really like people to chime in whether this makes sense or not, so that we can nail this down. The addressing scheme needs to be standardized in some way, right? And one of the things we've suggested in the last IETF is the following. We are using ULA addresses, so that implies the FD as the starting byte. Then we take off the domain name, which has been entered at the setup of the domain, example.com. We take a hash of that. Take 40 bits, lower bits, upper bits, I don't care which ones, take 40 bits of that. That makes a pseudo-random value, and that follows the ULA specifications. So from an IPv6 point of view, what we're doing here is okay. We've checked that. Then, while we wish we would know everything in advance, we don't think so. So it is very likely that in the future there may be needs for different addressing schemes. So we wanted to define an address type, 3 bits. All of this is thumb in air, right? So comments about length also welcome. 3 bits, such that we can say what we are writing into the reference model, or in the ACP draft in this case, is type 1 of an autonomic addressing scheme. Type 2 could be something else later on. Okay. And then there's the subscheme, which is the next 2 slides. On this, do we agree on that so far? Can I just have a show of hands of people who have an opinion? Does this sound reasonable? If anybody has an opinion. Is that something we could live with and get started with? One opinion, 2, 3. Does anybody think that this is problematic and we should not do this? Could you please speak up? I'd love to hear that. We have to have that discussion, right? So thank you.
Why is that 3-bit spotted type and 77? Why it's not 4 like 4 and 60, 76? Reason for my question is when like splitting addresses into pieces, it's like a very common and intuitive thing to do it on 4-bit boundaries. That's why I just, what's the reason for 3 and 77 versus 4 and 76 or something else? So to stay on a 4-bit boundary, what's the reason for deviating from the 4-bit boundary?
Now, you see, you're getting me. I've written this down ages ago, so I need to think about that. You know what? Let me go through this in my mind. No, I remember now. Actually, the next 10 bits make it clearer. So, sorry, this is, as such, actually looking at it, it doesn't make sense, right? Bear with me for the next slide, okay? And I think then it's going to be clearer. Because we define now a zone ID. And with the zone ID here, you have a 64-bit boundary. So this is a prefix, and that's the host part. And so while the prefix is set up somewhat in an odd way, shall we say, unusual way, I don't see why it wouldn't work, right? So again, the length of the bits up for discussion, right? I'm not married to exactly the length. I think we should be on the 64-bit boundary so that we have network and host parts. Now, the type we need because we want more addressing schemes in the future, and the zone ID allows us to do later aggregation. Keep in mind, this address scheme and the way we want to do that is a flat addressing scheme. Anybody in routing will now sort of like his neck hair will stand up. Flat addressing, where a node receives an IP address and that has no reference to topology at all for a large network, I think we'd get slammed, right? So we want the possibility to have some form of hierarchy in here. And this is the first attempt of having some hierarchy. I have some slides that explain better what we want to do with the zone ID later on, right? But how we plan to use it. This is now one address type. Now we could have subzones, for example. That would then be, if we really happen to need that, that might be another address type. So the zone ID is the first bit that's important of the subscheme. And I believe we should have a zone ID. And whether it's called zone or area or whatever, if you have a better name, come up. I'm not fixed on zone. It used to be called area ID. The OSPF guys didn't like that. Turns out zone is also used somewhere else. So no perfect term here. And then it's the device ID, right? The device ID is assigned by the registrar in a way such that it's unique within the domain. And we don't care how it's done. I don't think we need to specify that here. We could give examples, but as long as within a domain everybody does the same scheme, it doesn't matter what the scheme is. Okay? Note here, very important, the IP addresses that we are using here are really not locators. They are identifiers. And that also explains that when you put that into a routing protocol, you get a flat space. Okay. Second, slightly different subscheme, which is based on an idea from Turlich, which I like very much. Same thing, but now at the end here, add a V bit, a virtualization bit. Now, what exactly is that? This is what I suggest personally we should do. Next slide, please. The idea behind the virtualization bit is the following. We have started with the thought that an autonomic node is a homogeneous operating system, and that's that. Trying to implement that in our company, we have found out that it ain't quite that simple. We have a lot of virtualization going on in the network these days. So we have a hardware node, but in many hardware nodes, we also have VMs, containers, whatever, that sit there as well. When we went through the process of thinking, so how do we organize all of this? We came to the conclusion that if we have an autonomic function, it is likely better if we put that into a container, or if we have autonomic functions, that we put them into a container. There could only be one, right? But those functions may now be here, and you install a container on a device if you want to run that autonomic function. So now you need to talk to the controller element, as we call it. So that needs some addressing as well. Not the function itself, note, right? I stick to what I said earlier. The autonomic function itself does not have addressing, but the controller element does. This is still the autonomic infrastructure. So now you have different addresses. And if we now took the last bit or bits of the addressing scheme for that purpose, then within the autonomic control plane, we could just announce the aggregate here. You see where we're going? Say you take only 2, then you have 1 and 2, and you would announce, in that case, a /127. Routing table has 1 entry per node, even though there are different virtual elements in the node. We don't have to use that, but I think it might be useful. Yeah, Kiri.
Hi, Kiri D here, Kiri D. Compella. Why do you think that these virtual elements are related so that you're putting them in the same /126 or 120, whatever it is? Because if you say that in this physical element, I've got multiple virtual elements, they could be completely unrelated.
They could be completely?
Unrelated. And now you're giving them the same prefix. You're trying to aggregate. I understand that's always valuable, but they could be unrelated elements. They just happen to be physically on this Anima element.
Well, I would argue that if that is an unrelated container, it doesn't talk autonomic in the box, it's ignored in the autonomic, so you wouldn't see it. So what I'm not saying is that every container should every container should have such an addressing scheme. What I'm saying is, if you use a container, if that plays autonomic, then.
Not sure I buy it, but I have to think more.
Yeah, and frankly, we do need to discuss that, right? We may have made a mistake here in the thinking as well, so feedback is really welcome here. I think it's really easy. Getting a unique device ID should be possible with 64 minus V bits. Even having a single bit would be useful, because then you can actually on the port level fan out here to different devices if you need to. And so, but having the capability of announcing a /127, for example, sounds really nice to me, instead of having twice the addressing in the routing plane. Okay, so that's the reason why we want this zone bit. Can you please go one back? Yeah. So this was this V bit, right? And now let me go a bit more into the zones, what we wanted to do with the zones. Now 2 down, please. Thank you. So we ran into the problem where not all devices that we support are autonomic. Specifically, large core devices today are not. We then had service providers trying to implement the stuff, ending up in having autonomic areas, zones, whatever you call it, that in the end hooked up to a core network. Now, Ripple can deal with the routing protocol that we're using here, can deal with a huge flat address space. It doesn't really care. But as soon as you throw this into a VPN VRF, you actually may start to care whether you inject 10,000 prefixes here all of a sudden, especially since there would be a route reflector here that gets all of those updates. So the thought was very clear. We want on this router, on the edge to the non-autonomic part, have ideally some aggregation. And that's where the zone concept came in. So the idea was we give every zone a number, zone 1, zone 2, zone 3. That could be done administratively, that could be later figured out automatically, whatever, that doesn't really matter. But the zones get their number. And then the redistribution, next slide please, would look like that. So I'm blowing up this PE router here now. In the autonomic VRF, the one in the ACP, the one that makes the ACP, so the ACP here goes to other neighbors. There you would essentially have the loopback. You would announce the loopback, you would announce the summary route with RT export import and get the other summary routes back. That looks like a clean architecture to me, and that would be enabled by those zone bits. Let me make a break here. Does that sound roughly right? Right? Does it sound completely wrong? Or still some things to fix? Any comments? And now also, with this background, the lines, the alignment probably make more sense now, right? The 64 bits that we have now. Can you go back, please? One more, till we have the addressing scheme again. One more.
Michael.
Here, this one, yeah. Thank you.
Very quickly, that makes more sense, but still, I tend to think that doing a 12-bit zone ID and a 4-bit type makes it easier, like for operational reasons. Once you use the zone ID in the RT export-import, for example, these are things done in a provisioning, or in some, they affect operations. And for operations, it's certainly easier once you have to type in something or use it in whatever type of export-import or filtering, to have a 12-bit versus a 4-bit boundary. That's what I intuitively think. So is there a reason why you need those 13 bits? Would
No.
you get along with 12?
Saminir, give me a better number.
12 and 4.
Sorry?
A 4 for the type and sorry for that. 12 for the zone, 4 for the type.
Okay, be my friend. Honestly, no, I have no strong feeling. We need a number. We were fiddling with how many we need. We came more from the type side. The type 3 seemed the right number, 3 bits for type, and that left that for the zone ID within the 64-bit. But anything, right? We can do 12 and have 4 type. No strong feelings. Conceptually, are we on the right track? A few bits more or less, right? Okay, that's what matters really. Okay, thank you.
Actually, I got a quick clarification. Is this addressing stuff in the ACP draft or?
Yeah. This is the text of this is in the ACP draft.
Oh, that's fine. Because I get a little bit worried if that's in the reference model, because the reference model is an informational document, so this is more normative.
It is presentation oddity that I'm presenting.
Okay, good.
Ignore.
So,
Okay. Is that the first after the?
Yeah,
okay.
That's the first.
So then, what are the other open issues that we do need to discuss? And here we come, intent distribution is clearly not in this charter, so this is one of the future items. And as I wrote on the mailing list, what we really should do is have in the reference model a complete different section, clearly separated future work, such that Sheng's concern was that we should have all the future work clearly outside the reference model so that we can progress. But everybody who reads those future work items sort of thinks like, no, this is good to understand. We want to know where we are going with this, even in this draft, even if the standardization of it is not yet in the charter. So I think that would be a very good compromise of dealing with these things. But I'll get back to that later, actually, also in the slides. So, no, hang on, stay there, please. The intent distribution, here we are not actually defining how it works. It's just conceptually what needs to be done. There is a draft, so old model, the reference model just explains the concept and then points to the draft for the reference implementation of it. It should explain that the intent is flooded if indeed we decide to do that, right? That's still a discussion we have to have. Yeah, and all these are bullets that we need to haggle out, right? Does intent really have a long lifetime? I think we are agreeing with the discussion on the list right now more and more, but I don't think they're completely there yet. Yeah, and again, also that is a question that we should discuss. Next one, please. Now, functional overview. I've written most of the stuff, or at least a large part of the stuff. Even I don't understand what that means. This is not a good section title, and I'm looking for better names. This is really, in my view, the section that holds it all together. If somebody comes to Anima and has no idea what we are talking about and how all the protocols fit together, that's the section. That's the section that explains the adjacency table. I'll have a slide on that in a second. And how it's fed, what you do if you see certain things. Great.
I haven't read this, but how about theory of operation?
Theory of operation, okay. Thanks. Whoever takes notes, please write this down. One thought I had is behavior of an autonomic node, because it's really like if then else, right? It's really like going through the various states and seeing what it does. But yeah, good name proposals are welcome. Here the insecure discovery is not described yet, but it should be, right? Because it is a step in the life of a process of an autonomic node. Yeah. The alternative was, should this go into the ACP draft? Somebody raised that point. I think it should not. And the reason is because it also explains things before ACP. It explains what an autonomic node that has no domain certificate should do. And also there are steps to be done, right? An autonomic node without a certificate has to probe various neighbors and see whether anybody would let him in, so to speak. And that's nothing to do with the ACP. So I think this is good where it is. But yeah, comments are welcome. So here's this adjacency table, slides again from last time, but little discussion, and that worries me. So I would really hope we get, if there is concern, more feedback on this whole thing. So this is what it would look like. You have a node identifier as the key into the table. You note where you've seen this, on which interface, the address on the link. In most cases, that will be a linked local address, but there can also be, in some cases, for example, in the master case, there can be a remote next hop where you need to unicast, in which case you would have a unicast address here. The ACP address, if I have one, because if I need to talk to my neighbor, I need to talk to the ACP address, so that should also be captured somewhere. The domain, the certificate, validity, trust. Domain triggers the process. I have no domain, my neighbor has a domain, I shall try to bootstrap with this domain. I'm in domain example.com, my neighbor's in domain example.com, we shall establish ACP. So this table really drives the behavior of an autonomic node. We have validity of the certificate, is it valid? Now, if I'm example.com and I see example1.com, the certificate may be valid, but I don't trust it. So also that has to be noted. And trust can be overwritten, for example, later on by intent. Not part of this charter yet, but later on. With intent, I can say, yes, domain example1.com is not actually our domain, but it's the same operational entity, trust this domain, and you pretend it was the same domain. So you would overwrite this no trust here via intent. That allows you to actually go into different domains later. Okay, then how do we feed that table? One down, please. Oh, question?
5 minutes.
5 minutes? Okay, yeah. How do we feed it? So, number one, we have the discovery. And so here, you see, when you now look at that, you see how all of this comes together now. What Tölis just explained about insecure grasp, that's that. Right? So you go out and do a insecure ping, who are you? That feeds just the basics. It feeds the, maybe not even the UDI, but it feeds the link address and who you are. You may have a cloud redirect, which feeds that, that's going in here. That could give you an IP address in the unicast space, for example. You have non-autonomic inputs. You can have configuration. You could have configuration. My next AN node is unicast across this cloud. Why not? Right. So also that we need to allow. And here's a lot of overlap with the netconf draft. Right. What the netconf draft has could also feed this table to some extent. So you can come with DNS-based options, DHCP options, whatever. And so some of that is also in the bootstrapping draft, the other draft. Yeah, next one. And then what do you do? So that was how you feed the table. What do you do with the table? And yeah, there are various options, and I don't have to go through them in all detail here. I already gave a few examples. That is essentially explaining what you do with the table. And so that table to me holds together all the drafts. Because some feed into it, some feed out of it, and that gives the whole picture. Now let me finish and then ask for feedback. Next one, please. So, more open issues. Security and trust. We do have some security considerations. There needs to be more there. And also the infrastructure. We do need to do a review of that and put more time and work into that. The certificate format I already mentioned. We haven't fixed quite yet where this should go. Current feeling is into the bootstrap draft. Let's put it somewhere for now. My bet is that many of the particular components will still move around a little bit between the drafts. That's okay, as we figure out what is the best place to have them. The domain certificate should also contain the ACP IP address. Now that sounds really, really odd, but if the IP address is not a locator but an identifier, then it makes sense. Note again, and here's where the zone ID comes in, really gives it the wrong twist. So for that, you would have to set the zone ID to 0. And the way I see that, a node may have in its lifetime several ACP addresses with different zone IDs, but the rest always stays the same. Right, so the node may pop up in zone 0. You start with a network in zone 0. The autonomic nodes know nothing. They just turn up. Nobody has told them anything about zones. Starting point is always 0. At some point, the network grows. Let's take the simple case. The operator says manually, in this part of the network, from here downwards, you are zone 1. Nodes see that. Oh, somebody told me to be in zone 1 now. So that means I will now also respond to the ACP address with zone 1. And I will use that to communicate. And we can have automatic mechanisms to do that later on, right? So there's a lot of possibilities here. But the base ACP IP address without the zone ID, that's an identifier, and that should then go into the certificate.
Can you wrap up?
Yep, I'm at the end.
Michael, actually, as far as I remember, we had a security advisor for this working group who seems never show up.
She's sitting here.
All right, okay. So I guess you should give us the review for the security. Yeah, right. Yeah.
So this is Nancy Camwinjet. Yeah, I realize, and I just figured when you asked for reviewers, especially for the bootstrapping, since that has a lot of security implications, that I would have to review it, but I can pay attention to this one too.
Thank you. Thank you.
I think we are at the end. See if there's another one. Yeah, future section I already mentioned. So plan is now, and Sheng, I'm looking at you whether you're okay with that. There is stuff in the reference draft that has a page of content or so. And I think that content should not be removed. It was written, it gives good context, it gives people a good understanding. As long as we have it in a section that's clearly labeled future work, I think we should be all right. Would you be happy with that?
Actually, it's not about me, it's about RAD.
All right.
But Michael, leave it for now.
Okay.
We can discuss offline.
All right. Any concerns, shout.
Yeah.
Because I really feel bad about taking the stuff out. It doesn't feel right. Right?
Yeah.
It does give context, even though the context isn't in charter right now. We should be conscious of it at least.
Yeah, we understand.
Right. Certificate form we discussed. I think that's it. And the summary: we are making good progress. The stuff is coming together. We are building a skeleton with a core and arms and legs in all directions that actually stick together somehow now. There are still a few open issues. I don't think there's any serious open issue, any roadblockers or so. So we're getting there. The discussions we've had, all of that, bit boundaries and stuff still needs to be fixed. And with that, any questions? Is it okay to ask how people feel about the draft, whether we're going in the right way, whether there are concerns yet?
Oh, no, I mean, this draft we have a target for December, so I would like to ask the reviewer later. Yeah.
Okay.
So, please do bring those open issues on mailing list. Maybe one by one. After finish one open issues, then
Sure.
next
Thanks.
one. Okay. Thank you. Okay, this is the update for the autonomic IPv6 edge prefix management in large-scale network. This draft was adopted in last meeting and submit the new draft in January. It actually slightly, rewrites for the narrower scope only for the edge devices. That's according to the adoption condition, which you raised. Next page, please. The motivation is to validate the application and usability of Anima components, so mostly GRASP and SAP. In large networks, prefix management still depends on human planning. It's reached and stuck after initial planning. So we bring up the autonomic mechanism to dynamically and autonomically manage the address space in large-scale network. Ideally, we hope the administrators just configure a single IPv6 prefix for the whole network and the initial prefix nonce for each device roles. We expect there would be less than 10 roles in maximum. Next page. So it starts prefix requesting device needs more address space. It discover a pure device that may be able to provide the extra address space by sending out the GRASP discovery message for the prefix manager objective. So just to find out where the prefix manager is. Then negotiates with a discovered peer for the lead address space using GRASP message. By that, it set out the prefix objective. In a single administrative domain, the network operator match all prefix manager devices with the same intent rules, flat using grasp. For now, we are still not sure whether that's really should be named intent or not. That's another matter. We maybe change that like the ASI prefix manager autonomic service parameters, something like that. Discovery, negotiation, and flooding message goes through the secure SAP. So that means we don't need to worry about the security for the communication. Next page. The main change in the working group 0 version is we are now focused on prefix management at the network edge. But actually, the solution we describe is not restrictive. It could possibly be used in the core network or in other scenarios. The description is now much more specific about the usage of grasp. So the procedure of usage of grasp is carefully examined. So that's actually verified the grasp design so far. The mechanism is now intended to be prefix delegation friendly. If nodes support DHCP v6 prefix delegation, it could use it. If not, the grasp negotiation itself will delegate a prefix. Next page. This is the design for grasp objectives in CTTL notation. We have the objective as prefix manager. It contains the flag and loop count, also the flag for prefix delegation support, the length of the prefix, and the prefix which in binary. Next. This is the intent prefix manager objective. It set out the intent which contains the prefix lengths for different rows. The text object would be relevant intent statement, so format to be discussed. Translate it as a single string. Alternatively, we would use the proposed COBAR encoding for young, possibly. Okay. The next step we want is to get review and comments. We also want a volunteer to try writing a prototype prefix manager autonomic service agent. The easiest way would be to write in Python 3, since there is already a prototype grasp implementation and API. So that would be validated in the running code stage. That's all. I mean, if any volunteer would like to write the code, could contact Brian or me. And actually, we do have the plan to do that coding by ourselves. But we would like to get more prototype and maybe potentially for interoperation. Okay, thanks. Any question? All right.
So we're not going to have an update on the stable connectivity. That draft has been fairly stable. So last comments were around last year. So I think that one we can look for last call in Berlin. So I wanted to take the remaining time here for a presentation without a draft right now. Hopefully we'll get around that to Berlin as well. So this is an open source implementation of autonomics. It's called SNBI, and based on Open Daylight as the platform. Next slide. So where did this start from, right? So we wanted to have NOC equipment to be autonomic, and the starting point, of course, is in the stable connectivity that the NOC equipment wants to use the autonomic control plane to manage the network, and then it should be autonomic itself, have all the security. So we were thinking, okay, how can we start building that out? And so Open Daylight is the industry standard open source SDN controller development platform built around Java. So we started building this out in Open Daylight, called the project in Open Daylight Secure Network Bootstrap Infrastructure SNBI, built autonomic registrar code in Java in the standard ODL development environment, and then basically just started to stumble with the whole let's do everything inside ODL in Java when it came to the autonomic control plane channels, because doing something like a secure channel IPsec in Java that should be plugged underneath the operating system level TCP/IP stack, which is used by the rest of Open Daylight, turned out to be fairly challenging. So at that step, we changed our implementation strategy somewhat. Next slide. And basically arrived at the implementation model of what we call an SNBI forwarding element, which is really an autonomic router implementation that we package with Docker. And Docker is primarily the containerization to make deployment very simple, because it includes all the Linux dependencies that usually make porting software from one piece of Linux to another version very difficult. And so that software architecture has two big parts. One is what we call the host package, which is platform dependent. So that's where all the Linux dependencies comes in. And that's basically what you would need to change if you wanted to take, for example, this open source code and port it over to a non-Linux or non-standard Linux commercial platform, right? But all the non-host package pieces of SNBI are open source and are meant to be portable to different operating systems, different platforms. Next slide. So what we are currently having in Docker are really two big pieces. One is the registrar function that is, as I said, written in Java inside Open Daylight. So we have a version of Open Daylight in the container that's stripped down to just the pieces that we need to run a registrar. So it's not meant to be the full controller itself, but just the ODL piece that builds a registrar, and that basically does whitelist configuration, enrollment, as we have it defined in the Bootstrap. In general, and then also an internal certificate authority based on the Bouncy Castle open source component. Then we've got the forwarding element, which basically has the SNBI daemon, the platform independent code, which does the neighbor discovery, device bootstrap, proxy bootstrap. The protocols used for all of that are based on Cisco's commercial autonomic implementation, so not GRASP yet. So that's exactly one of the interesting pieces that would be great to get to. And then the host package is exactly using the Linux infrastructure in the kernel. We're not having any kernel changes. We're just plugging available kernel pieces together to build IPsec GRE secure tunnels. So that's using unstrung for IPsec, and then the routing is normal Ripple routing, as we've been proposing it for the ACL, using unstrung, the implementation of Ripple from Michael. And yeah, the only dependency is fairly new Linux kernel, because some of these dependencies against the kernel modules required some bug fixes that only came in fairly recently. Next slide.
Question. Do you actually have a plan for GRASP implementation within this?
No, there is no GRASP in this right now.
I know. Do you have plan, future plan?
I need buddies to put cycles in. That's I have a plan, of course. I don't have the buddies right now, right? So I'm looking at everybody who could give me buddies for that. Yeah. So this is basically here the simple example, what can you do with it, right? So basically, SNBI gives you a full autonomic network. You know, it looks great on the outside, is actually great, very rough on the edges, so in the details, there are a lot of things we'd like to improve. But really, you know, simple autonomic deployment, you've got 3 devices, somehow you got them in greenfield, and they have this SNBI software running. One of them actually, you know, needs to be the registrar. So the registrar is what you're using there. You set that up first, you configure it for a domain name, then basically that device enrolls itself, becomes autonomic, and then basically when you plug the next device onto it, they will automatically build the ACP. Well, first this device will enroll with the registrar, then the ACP is being built, then you connect the second device will use that first device as the proxy to enroll itself, get a certificate, build the ACP, voila, at the end, you can reach through IPv6 the ACP, both of the devices. And obviously, you know, if we had more Raspberry Pis in our lab, we could have done that with an arbitrary large network. So, next slide. So here just a little bit more of the detail, how it looks under the hood, right? So this is just, you know, the Docker container, the different components that we're relying on, just IP Route 2 in Linux, unstrung, strong SWAN, GRE configuration. So that's just inside. Next slide. Yeah, and this is just, you know, what I was trying to explain in the prior slide, how step by step, when such a device comes up, the individual parts of autonomic networking come into play, right? You see here is basically the forwarding element, down here the host package with the Linux specific things, the daemon that we consider to be quite independent of Linux, and then here the controller registrar in a Karaf package, which is kind of lightweight ODL. And I'm not going to go through the individual steps again here. Next slide. Yep, so basically that stuff is all out in the open source. So SNBI dev under Open Daylight is the mailing list to contact us. There is a tutorial how to install this. This just came in with a Beryllium release, which is just out since a few weeks. We've got a wiki on the SNBI page, release plans, more documentation. So please, you know, try it out. Talk with us on the mailing list if you're interested and have questions. Next slide. I think
that's enough.
That's it. Yep.
Any question?
Hey, was I too fast again?
No, perfect timing. Yeah. So that means we finish our today's session, and our next session will be Thursday afternoon, session 2, I guess. All right. Thank you, guys. See you Thursday. I did.
Before you folks leave, anybody who hasn't filled out the